All right, we're in section 7.3 where we are going to use similar right triangles. So if you look at the box to the right, it says if the altitude is drawn to the hypotenuse of a right triangle, then two triangles form are similar to the original and also each other. So what we have here is the large triangle, triangle ABC. And at point C is where the right triangle is located for that large triangle. By talking about the altitude means is you draw a line segment from where the right triangle is located right here, and it goes 90 degrees to the opposite side. That's why we have the 90-degree there. We represent that by point D. And what that does is it creates two separate right triangles, the side of our large right triangle. And what makes this one, it makes it nice is not only is like triangle CBD and triangle ACD similar to triangle ABC, but also the two triangles that are formed are also similar as well. So I actually kind of I kind of separated them here on the bottom. So triangle CBD is also similar to triangle ACD. Okay. What that does, or one of the things that we can take note, is that all the definitions of it being similar remain the same. Corresponding angles are congruent and sides are also proportional. So one of the things that we can do to kind of help us solve, especially for unknowns, is using the geometric mean. Geometric mean theorem helps out, and in this case, where one line segment represents multiple facets for the specific right triangle. So what I would like you to do is, so if we were to look at the large triangle, triangle ABC, this line segment right here would be for the hypotenuse, okay? And then the other two legs, one leg is going to be larger than the other. So in this case, AC is the longer leg of line segment BC. So AC, I'm going to call that long leg, and then BC, I'm going to call that short leg. So now if you look at the two smaller triangles that are inside the large triangle that are formed by the altitude, AC here is your hypotenuse. BC here is your hypotenuse. And AD is your long leg, and CD is your short leg. Over here, CD is your long leg, and BD is your short leg. So when you are writing these proportion statements, what you have to do is make sure that you are consistent um, in each of your lines. So if you look at BD over CD, BD over CD basically means that, all right, well, BD was short leg and CD was long leg. And if you look at CD here, this is short leg, which is how it's represented, and AD, which is long leg. So if you look how they set this up, all the short leg values are in the numerator and all the long leg values are in the denominator. They're consistent throughout the entire proportion, okay? So if you were dealing with hypotenuse, or if you were dealing with, you know, hypotenuse long leg or hypotenuse short leg or vice versa, you just got to make sure you are consistent throughout the entire um, proportion. And if you notice here, these two values are the same. These two values are the same. These two values are the same. That's going to help you out when you are solving for these unknowns because sometimes they don't give us all of the information that we would need to find all of the values of each side. So you just can't pick any proportion you'd like. You'd have to be kind of specific. More often than not, were the ones that are the same are probably going to be your unknown, your value of x, your value of y, so on and so forth. Okay, so looking into that, we need to, it says identify the similar triangles. Then they want us to find the value of x. Okay, so looking at this one, what I want to do is, all right, so by looking at, talking about the statement that we had um, on the first page, I have my big triangle. I'm going to call this triangle EGF. All right, so that's my big triangle, EGF. And so I can say that this is going to be similar to triangle, let's see here, so E and G were the short leg. So let's just look at this triangle here first. So between that, so the short leg is EH, so I'm going to say triangle EHG. So that is my first similarity statement. The next one is triangle EGF. I want to see that's going to be similar to, now if I look at this triangle here, my short, it's going to be triangle, looks like GH, GHF, yeah, GHF. And then finally, I can say that triangle, I'll just write it in, EHG is going to be similar. So EH, that's the smaller side length. So I can say that it's going to be triangle GHF. All right, so all right, so now what we want to do is we want to find our value of x. So what makes so what we're trying to do here, so we got x is in this spot and it represents a couple of items for whatever triangle you're trying to look at. So if I'm looking at triangle uh, EHG, that will be considered the long leg for x. When I'm looking at triangle GHF, it's the short leg. So all you got to do is figure out how you want to set up your similarity or your proportion statement, and you just got to make sure you're consistent. So since we're dealing with long legs and short legs, all right, I'm just going to put short leg on the bottom over long leg on the top. So looking at triangle EHG, it is considered to be the long leg. So I'm going to put X over here. The short leg in that particular triangle is, well, I guess it doesn't have one. So, so what I can do is, all right, sorry about that. So what we're going to do is change this up. So what we do know is X here is the long leg, and we also know that in this case, 3 is considered the hypotenuse. And so we'll call that 3. This is going to be proportional to, we can look at the big triangle, which will make this nice. We know that hypotenuse is 5 over the long leg, in this case, is 4. So when I do the cross products, I get 5x equals 12. And then I just take 12 divided by 5, that means x is going to equal 2.4. Okay. If we look at uh, this particular example here, we got to look at our large triangle, which is going to be triangle LMJ. LMJ, this one's going to be similar to, we'll just call this point Q, we'll call it. So this is going to be LQM. Triangle LMJ is going to be similar to, so looking at this one's going to be triangle, so it's got to be short leg. So it's short leg, LMJ. So in this case, it'll be triangle MQJ. And then the final one would be triangle MQJ will be similar to triangle LQM. So those are the three similar triangles. And again, we're going to have to find uh, something that we know. So I'm just looking at this small triangle, LQM. It appears that X is my long leg over, I know that LM is my hypotenuse. So looking at the larger triangle, my long leg is 12 over my hypotenuse is 13. I can set this up now to solve for x. So this is now 13x equals 12 times 5, which is 60. Divide everything by 13. X equals about 4.62. All right. So again, looking at these ones, they want us to round round to the nearest tenth in this case. Okay, so looking at this, given the information that we have, we could say that x over 2, x is my hypotenuse, 2 is my short leg. That's going to be proportional to 10 for the big triangle is my hypotenuse over my short leg, which is x. So consistent all the way across. Multiply cross products, I get x squared equals 20. Gotta take the square root of both sides. Square root of 20, rounded to the nearest tenth. X is going to equal about 4.5. Okay. Looking at this triangle here. So if I look at the big triangle, looks like I got x over 9. X in this case is the hypotenuse. 9 in this case is the long leg. And so this is going to be proportional to the hypotenuse of this triangle right here is 9. And I got a long leg of 7. So again, I go over here. This is going to be 81 equals 7x. And 81 divided by 7, rounded to the nearest tenth, is 11.6. Looking at this final example, uh, looks like I'm going to use the two triangles that are in the inside of the big triangle. So looks like I have 5 over y. And in this case, we're looking at 5 is the short leg. And y in that instance would be our hypotenuse. And it could be proportional to that won't work because what we have here is 5 and 3. Oh, but we can figure out what this is because I know that 5 squared plus, so that would be what, 25 plus 9 equals 34. Square root of 34 equals, this is going to give me 5.83 roughly. So I can figure out that hypotenuse here is going to be 5.83 over the short leg, which is 3. So then I got 3y equals 5 times it by 5.83, which gives me about 29.15. Divide that by 3, and when we're rounding things to the nearest tenth, it is 9.7. And that is being able to use similar right triangles. Hope this helps. Till next time.